right? So you can explain things that didn't work, right? Spend some time on that, and I'll give you credit for doing that. Okay? As long as you try to do them the right way, I'll give you credit for them. Okay. So, and remember there's a page limit of 4 pages per student. If you have more charts and plots, they should fit in those 12 pages, right? I've had reports in the past where someone decide for some reason they need to write a lot of text. Okay? Okay? You don't need to fill 12 pages edge to edge with text. Okay? And all the charts and plots were in some appendix. That's not okay. Okay? These need to go in the 12 pages. Everything like this. You can do more in the appendix, but the main part should be in the 12 or 8 pages. Yeah?
Do you want our source code as a separate thing, or?
You know, I'm unlikely to look at it. If you want to attach it or make it available, you know, I might look at it in some cases, right? If I'm wondering about how you did something, I want to try and give you more credit for something, or if you want to highlight something that you did, so I can kind of see what it's important to see the actual snippet of source code that does it. That's great. I will unlikely look through all of the source code, unless I have doubts about something. Right? I'm like, oh, this is so cool. I can't believe you actually did this, but you have the source code. Oh, you actually did this. That's really cool. Right? So if you have it, no harm linking it or having an appendix. It's going to be a PDF anyways. I'm not going to be cutting down trees to print all these out. Right? So feel free to attach it. Yeah.
Are you going to have a LaTeX template for this, or like is it just open-ended?
It's open-ended. Not totally open-ended. There are rules like 11-point or larger font, single column, margins at like it's like 1 inch. If you use the default LaTeX template, the margins are like 1.5 inches, right? So you can make them. It's standard to make them a little bit bigger, to make them 1 inch, and 11-point font is pretty good, right? But you know, you don't need to do much beyond that. You know, you can take the homework templates and modify those if you like. That's fine. But I'm happy for you to kind of put your own personalization for these things. Yeah. Okay. So other ways where people lose points. People lose points if, say, if they use a distance to model their problem and they don't justify the use of that distance. This happens. I've discussed some of you who did that in the intermediate report. You did lose points in the intermediate report, but if you do that in the final report, you'll lose points, right? If you do like clustering and you claim they're clusters when there clearly are not clusters there, I'm going to say, you know, I don't think you got this concept. You didn't transfer it onto real data properly. Okay, so don't overclaim something because you want to see something in the data. Okay. If you go over 12 pages for 3-person groups or 8 pages for 2-person groups, you will lose points. Okay? You could put stuff in an appendix, that's fine, but I should be able to kind of get the gist of it after reading the 8 or 12 pages. Okay, so don't go over, don't make the font too small, just make me mad. Yeah?
What is the percentage of distribution you have on each, like what did you do part? I can see how someone can like go, you know, 3/4 of their paper talking about what they did, like an implementation and stuff.
Yeah, so like think about, explain your data as like, could be like a page like your data collection report, right? That does not need to be too different from that. Title, motivation could be a page, right? So then it depends, and it could be a bit longer, especially if you have a larger group, right? These will depend greatly on the groups, right? Some groups, you know, for an average group, I would say most people are in the average group range or above, right? Average is not average in the statistical sense, but in you kind of met roughly my expectations, and then some groups will go beyond my expectations, and that's where you'll get more than 45 out of 50 points. And so where do you put more effort? Some people have the data collection and the wrangling part of it takes up half of their report because that was the challenging aspect. So it really is going to vary. Sometimes there's a lot in the artifacts, right? Because you you did something fairly simple, but you ran a lot of experiments and tried to draw a lot of conclusions from it. But in general, this is the largest part. What did you do? All right, any questions about this? Okay, all of you are going to do great. I'm happy if I can give all of you great scores. That makes me happy. Okay, so let's talk about so PageRank, and this is the key technology inside inside Google search. Okay, so this is what really made Google searches work, and to explain this, we're going to kind of talk through the history of like search engines and kind of build up what people did, and we'll see how they came to PageRank and why this was superior to what was going on before that. Right, so first question is, what is a search engine? Right, so how does a search engine work? Aside from like, there are two parts to it. One is you type in, all of you know how these work, you type in a keyword and returns a list of pages, right? And so mechanically, it needs to return the list of pages super fast. So there's not a lot of computation that goes on at the initial, when you actually do the search. It's all pre-processed. A lot of this is pre-processed. And so internally, it runs on what's called an inverted index. And so you have some keyword you'd search in the text box. And so then this has a, it basically has a pointer to each of these words, right? So, if the word is pie, you search for the word pie, then there's a pointer that says, okay, you search pie. A lot of other people search the word pie. I'm going to go to this index, to this place where I return the results for the word pie, and then this has a list, basically a linked list of these web pages. Okay, and so and then it displays the top 10. Right, so then you have this search up here, and then you have pi.com. This is one here. Two is so baking.com. And this is two, and so on. Right, and it kind of has web pages that should be relevant to the word pie in some way, and then it just typically it explains the top 10, right? And also usually your browser window looks like this, and you don't even see all 10 of them. You see like a top 3 or 4. And they've run statistics on this, right? What percentage of searches do people actually scroll down the window past the top 3 or 4? Less than 10%, less than 5%. What, if you go down past 10, you click onto the next page. What fraction of people actually click onto the next page? Way less than 1%, like less than 1/10 of 1% of searches click onto the next page. Now that number used to be higher. Right? It used to be more people you'd have to go through, and you might go through a few search pages before you found something that you like. That's because search engines have been improving. Okay, so there's, if you haven't thought about it, I don't know, when you first started doing your searching on the web, it's gotten a lot better than it used to be, and that's even after the initial after Google came out. The first version was not as good as what's going on now. They'll often like preload some information. They'll put like stuff over here and up here. Sometimes this is ads, sometimes it's like a map. You type in the name of the location, it'll put a map, you click there, you go to the map, or this is like a Wikipedia article or something that has some predefined like knowledge. Like if you type in like, it's like Utah Jazz, it'll list the scores of their most recent Jazz games. So you don't have to kind of go down the list to find it. So it's kind of, so it really needs to pre-compute the first part really well, and then after that it can be not as good, and people will keep searching. So it's really optimized what are the most important websites. Yeah.
So conceptually, what makes this index inverted? Like, how is it different from just a normal index?
So it's usually called it's basically just an index that's called an inverted index. Yeah. So if you look up this up in the literature, they call this structure of keywords mapping to these list of web pages as an inverted index. You can build other sort of indices where you do like range queries and so forth on top of data, and that would be more like a regular index. This is not, not really doing range queries or other thing like that. I'm just pointing directly to things with just like I know, okay, it has this keyword, I've identified it, that is a pointer to here. Now, sometimes you will use more than one keyword, right? Pie and apple, right? And then it will somehow join those two lists together. And there are some mechanisms for doing that, right? Sometimes things are more rare and it needs to combine together certain other keywords. There are kind of some other ways of doing that based on this, this inverted index. Okay, so the main challenge in doing a good search engine, other than having the space to kind of store all of this, which is no longer really an issue because people have been searching for a long time and Google has plenty of storage space. This doesn't take that much space, although they do a lot of job to compress this, is to kind of come up with a good ranking for the individual keywords. Okay, so this is the real challenge in here is, so the big challenge is ranking pages for the, based on the keywords, or on short string of text, whatever it's asking. There's other search engines like Ask Jeeves. At some point, you're supposed to type in an actual question with the question mark, and then that was supposed to let them search a little bit better. It did never do that much better. Just the keyword, people eventually learned how to search by keywords. It took some training probably. I know it took my parents a lot longer than it took me to figure it out, but now I think you're probably all trained to search by keywords, right? What is a good distinguishing keywords? Okay, so how do we address this challenge? Like, how do we rank pages based on these keywords? Right? Rank web pages on keyword. Now, let's use as the example pie. Okay. So we've learned some stuff in class. I've actually discussed this early on in the semester. Right? And so the one thing we talked about was you can build you can do things like so k-grams on the text on the page, and then you can quickly find which words are close to this. For for the word pie, you want to use Cosine Similarity with just the word pie, right? So I can just look at the word pie, which web pages have the word pie, or keywords or k-grams that have the word pie so involved in them. Okay, and so with this, plus the ideas from min hashing, to extend back into the tail more, this was basically one of the ideas that powered the Alta Vista search engine. Who's used Alta Vista back in the day? Okay, so a few of you. This used to be, Alta Vista used to be an awesome search engine. How many have never heard of Alta Vista search engine? Okay, so this lecture gets dated more every year, but it's, you know, this was the base of this technology. What became a little bit easier to talk about instead is just using just the cosine similarity between words. And so where you look at some, let's say you have some vector pi, right, which is 0, 0, 0, and then it has a 1 in the location for pi, right? This is the location in this bag of words vector for pi. I count how many times it occurs, and I create also a bag of words vector for each page, and then this is going to have some counts for each of let's say this, each of these words, you know. And so if a page has the word pi on it 7 times and not too much else going on, then it's going to have a high similarity with the vector that only has a 1 vector and pi. Remember, cosine similarity takes out the normalization and essentially normalizes these first, and then looks at kind of the distance on the circle, which ends up being a cosine. But you could just think of the Euclidean distance between these vectors once they've been normalized. Right, so if a web page has a lot of the words pi on it, it's going to come up pi to search that has the word pi here. Okay? So what can go wrong? What can go wrong if this is your search engine? Right, if your search engine works this way in order to rank web pages. I want to search for pi. I create a bag of words vector for the text on every web page. You know, and I look at the most similar web page, and that's the one that's going to be ranked the highest. Yep.
Pages can just put as many nonsense words as they want to grab attention.
Yes, I want nonsense words, but I don't just want, usually you'll target a specific search, right? Say I want to be on the top of Alta Vista's search engine every time someone searches for pie, right? If I'm selling pie ingredients, right, then I want to come up first, right? This drives viewers, which ultimately is advertising dollars, yeah.
There's no sense of like context in there, as in other, so the vector for pi should have partial values for other words that you know could be a hit.
Yeah, good. So I might want to also have words like apple and hot and recipe and so forth. But even before that, there's a problem that can happen here, and then we'll talk about this adaptation. What I can do here, and what was commonly done, and I think I did this on a web page at some point, is you put many copies of the word pi, and you do this like in the same color font as the background, and then you put these in really small font at the bottom of the page, so you can't really see that they're there, but it has the word pi over and over and over again. And I think I did this on some web pages I built in like a long time ago, and this worked. This worked for basic search engines. This worked. This would make it more relevant for that particular keyword because you have that keyword in there a lot of times. Okay, so so then they said, okay, just having the word pi a lot of times is not good. So the next thing to do is to so you can instead add more context, right? So if I search for pi, then I create a vector. Pi is not just having a 1 in the spot for pi, but I'll also have a 1 for things like like things that have to do with pi, right? So I'll have for the spot, this is for apple. That's so that's my favorite pi. Maybe you have 2 for it has to do with recipe. How do you figure out, how do you figure out what these words are? You have to have some example web pages. So you have, other things are still 0, but you somehow convert the search word into this vector, which is more informative. It has other information involved in it.
And what about the different meanings of a word?
Right, so if there are multiple meanings of a word, then you have to somehow figure out how to populate these different meanings. Historically, they didn't do a very good job of doing this. Now there's effort to make the search results actually be diverse. If there are multiple meanings of a word, like apple could be talking about the fruit or about the company, you want to make sure that in the first 3 or 4 search results, you give instances of all the main things. And so what they'll do is they'll take all the web pages that have to do with Apple, and they'll try and cluster them by content. And then they'll find the most representative one in each cluster. And so this is kind of what's done now. There are more complicated things about this. At some point, I want to show 2 things for Apple Computer. Like I want to show the Apple website, but also things that have reviews about the Apple website. And maybe I want to show those before anything about the fruit, because that's what people tend to click on. But you kind of have to learn this balance, and it becomes a more complicated trade-off. This is a more advanced thing that is a more interesting challenge. But these are great questions. At this point, if I wanted to kind of populate this vector, I would try and figure out what are good web pages about that have to do with pi. Figure out what are the other especially significant keywords on them, maybe by doing TF IDF or other things that kind of figure out what's special about this page. And hopefully they're diverse. And then put those into the search vector. Okay? And so then this was a way that gave more accurate results by kind of figuring out what are other interesting keywords and diversifying the search vector in this way. But what can then break this? Like if someone wanted to elevate their web page, how could they do that for a search engine, even if I use this diversified set of words? Yep.
Just have this diversified set of words in their website.
Yeah, so now the one thing is the search engines, they would not tell you what these diversified words are, right? At least not explicitly.
Could they copy the entire web page multiple times? Because,
yeah, right. So what you would do back in the day, and there were companies that would do this for you, is they would, and it wasn't that hard, but you would go and you'd search for that word that you want to be high on. You'd look at the most popular, the top return results for that word. You'd take those web pages, you'd copy their content, and then you'd copy that into the bottom of your page in really small font in the same color as the background. Right? So now you copy entire popular web pages, and so you can kind of figure out those web pages are aligned well with this vector, and so if you copy them in with the right ratio, maybe more times for the top result than the fourth result, you're actually going to start mimicking this vector, right? And maybe you filter out the stop words that you know are not going to be in there, and you can actually try and figure out what the actual vector is, and then copy this into your web page, but don't make it part of the text that's visible in HTML. And HTML is a mess, right? So it's hard, kind of tricky for a browser to for a search engine to figure out what is actually displayed and what is not displayed. So it just takes the text and tries to figure out what the text is typically. Yeah. So this didn't. But this was kind of like this kind of playing with these sort of tricks was kind of the state of the art for a while. Yeah.
How often that vector changed back in the day? I mean, they used to change that vector, the keywords.
Yeah, so like search engines, now they want to try and make this as automated as possible. These like Alta Vista sort of search engines. I've heard stories that like Andre Broder, who was the guys who invented like min hashing and a lot of this stuff, he was like he was like trying to kind of kept optimizing every day this search engine, try and automate it and rebuild the index like every day to try and make it better and better. And they were competing against that search engine and like InfoSeek and these other ones that were trying to be better. There was really kind of a wild west at the time, and they were trying different things, changing parameters and rebuilding these measures. So they try and automatically figure out how to populate these vectors to give a better search engine. And there are other tricks like what are the actual keywords in a search, and there are a variety of sides to this. Okay, so but this was kind of the state of the art for a while. There's another angle to this. So how did these search engines know about the pages that it was searching on, right? So how do they know about which web pages to put in their index, right? They were providing what is like a phone book for the entire web. There didn't exist a phone book for the entire web, right? There did very, very early on when like Utah was one of the first 4 hubs in the internet, right? But this quickly didn't work anymore, right? There were, what was it? There was this text-based way of doing all this, where there was blinks. There used to be an index, but then with HTML,
Just start at Wikipedia and then for search.
yeah, this is pre-Wikipedia, right? I don't know if it was but Wikipedia was not the behemoth it is now. There were these things called these crawlers, which is like a program you could write that, think of the web as a spider web, and the crawler is like a spider, and what does it do? It crawls across the web, right? So what does it do? It goes to a web page, it starts someplace, and then it follows the links, and it records the page, and it sends it back to the server, or puts on the server, right? So think of there's a graph of the web based on web pages linked to other pages, and it just kind of does like maybe like a random depth first search of the web. Just walks around from page to page. Okay, and it records it, and so if it finds a new page, it throws it in the index. When it gets to the page, it gathers all the text on it, and that's what's used to put it in the ranking. Right?
So that tells me if there was a new web page, it would probably be unlisted for a really long time.
Yeah, it used to take a while for your web page to get listed. Now Google is more on top of these things and kind of it kind of knows how much to check different domains, and it can run these things. It's much more computing power, can run these things much more efficiently. But sometimes it would take weeks for a new web page before it got listed on these search engines. So this used to be much less efficient. Now there are always these crawlers going around. Yeah.
So like if you were like a particularly malicious person, you could have a web page that just has a bunch of URLs and makes it very hard for the crawler to do that efficiently.
Oh yeah, so you could have a lot of links. You know, this can be good and bad, right? The crawler, if it has a lot of links, it can spawn a new thread, or it can tell its friends to kind of go back over here. You'd run many of these in parallel, right? So it might keep track of this page had a lot of cool links I haven't seen. It kind of keeps track of, it can read them and say which ones haven't I seen before, and then it can go and kind of remember to go back to those. So that's, in this sense, that's not bad, right? Having just a lot of links is not, say, a lot of bad things. Okay, so but with these crawlers, there's some extra information that we haven't discussed yet that can be used before, right? How it got between these web pages was it used these hyperlinks, okay? And how many have written basic HTML? Anyone hasn't written basic HTML? Okay, it's I don't know. You should make your own web page. You'll feel a bit better about yourself. Well, I didn't mean it in that way. But like, just it's like trying Python out or something. You're like, okay, this wasn't so bad, right? Not that you should be ashamed if you use like if you don't have one or something like that. Okay, so someone left. Okay, so if you remember how this works is href, which is the actual this is the new page URL it links to, and it has text, and you close it off here, right? And so when you link to this new web page URL, what's really informative text, more so than the text that's on this page, is the text that was used to inform someone should they click on it, right? If I have my own web page and I said I found a great website all about pi, right? I'm probably going to put pi in this text, right? So this text, this is very informative, right? The text that's inside of the hyperlink is very informative about what this web page is about, right? So this is also like a super informative piece of text to build into the index. I don't just want to use the text that's on the page, but I want to use the hyperlink text that points onto the page, right? So this actually, adding this in became kind of really improved the search engine quality as well. As long as you're finding the web pages by the crawlers, you know which page is linked there, and you know kind of what the text is. If I'm on a page, I don't know what links to me. I can't go backwards. But because I discover them via the crawlers, I can store this information, right? So I can build this into the kind of, so then you put this into, bag of words rep for the page, right? For the link to page, and this helped a lot. Okay. Okay. So, yep.
So should the text be defined as a keyword, or should it be like more defined as a page?
Well, think of I have like if I have the page, I have the bag of words vector, which looks like, it has v1, v2. These are all the words which are on the page, right? These are, this is based on words on page, and what you would ultimately do is you would add to it, so all the hyperlinks, the text from the hyperlinks, I would create a new vector, and I would do something like I would take the sum of these two vectors, right? So I would somehow add them together, maybe with some weight. How much weight do I put on? How much weight do I put on the hyperlinks versus the bag of words on the actual page? That's kind of a trade-off, right? But I want to create an ultimate vector representation of the page based on some combination of these two things, right? And then I can do cosine similarity to determine the most similar web pages in the same way here. Okay. Okay, these crawlers, though, are not the only way that that people created these this index, right? There's also just a there's also just a regular index web page, and these were just pages that were hand curated lists of links. Right, so you were suggesting before, these pages that just have these lists of links would be problematic to these crawlers, but in fact, these were super useful. People, some people would spend all day just browsing the web, and you know this was a thing to do even in the early 90s, and so they would just, and some people have the idea, well, these are the pages I found that I really liked. I'm going to keep track of a list of these pages, and I'm not just going to keep it for myself. I'm going to make it stored in a public web page, right? And these are just cool pages. So I just hand-curated a list of links, and maybe they're organized in certain sections. And so in fact, the most famous examples of these were, so was Yahoo, which is still around today in some form, and there's another one called LookSmart that was a competitor of this. Okay, so the story of how Yahoo was founded sounds a little bit like how Google was founded. There were a couple of Stanford graduate students who sat around all day just browsing the web, and they built this. You know, while they were supposed to be getting a PhD and doing research, they built this list of links and became so popular, people asked to advertise on it. They would pay them to put in links, and they started this Yahoo company. Okay, so this was an enormous company was started this way. So Yahoo is still got a big presence on the web. Now, if you go to their webpage, it doesn't look like this anymore. But in the 90s, it was not clear which way would work out on the web. Would this index work out, which is more like a traditional phone book, or would these automated search engines be more popular ways to kind of go across the web? And it was not at all clear which was going to be the dominant way to navigate the internet. And for a while, Yahoo and LookSmart were probably doing better. They were easier to use. They were more reliable, and they could, because they were making money, they could pay people to browse the web all day. And there are still companies that kind of do this for like news. They find news stories and so forth, but they people to browse the web all day and curate this list of links, right? And this was a popular way to browse the web. So who remembers looking at Yahoo back when it was like this? Okay, so this is even a bit more dated, but this was a very popular thing to do, believe it or not. So Yahoo is now basically a media website that has a bunch of other satellite things they do. So how popular do you think Yahoo is nowadays compared to other sites on the web? Bad? Yeah. No, okay, I'm not talking about you. You're all tech savvy, right? All of you probably use Google, or maybe like something like DuckDuckGo if you're really into this, which promises not to track you, kind of an alternative. I don't know how they'll make money, but okay. So Yahoo is still. I looked it up before class. According to several measures, a couple independent measures, is the 7th most popular website by traffic. Okay, it's still a big entity. People's, you know, like people use it because it includes like Yahoo Finance and sports and so forth, but a lot of people still use it.
Email service.
What?
They have email service.
And they have email services, and I think this is part of it. What do you think the top 10 websites are? So I'll just list them off here. The most popular website. So number 7 Yahoo.
Google.
One is Google.
Amazon.
Amazon, actually, yeah, Amazon comes in at 10.
Bing.
Facebook.
Bing is not in the top list. But Facebook is number 3.
Twitter.
Twitter was like 12. Yeah.
Instagram.
Instagram is like 16, 20.
Netflix?
Netflix, by traffic, Netflix is up there, but not by number of unique visits.
What about YouTube?
Yes, so YouTube is number 2. So Google owns the top 2.
MSN?
Nope.
Wikipedia?
Yes, Wikipedia comes in at 5. Guys, think broader.
Alibaba?
Alibaba, that's a good guess, but Alibaba is lower. I think unless it has, yeah, I don't see Alibaba on here. But
Baidu.
so Baidu, yeah, that's number 4. Okay.
Is any Stack Exchange website?
No, the world's not as nerdy as you think it is. So, although there is a nerdy one kind of up there a little bit.
Reddit?
Yeah.
Yes, number 6 is Reddit. I didn't realize Reddit was that big, but
Instagram?
IMDb?
Yeah.
IMDb, no, that's IMDb is.
BBC.
I don't see it. What?
BBC.
No. There's only one other that might be kind of newsy, other than Yahoo.
Oh, CNN.
I'd say BBC or maybe Al Jazeera.
What? I'll just no. There's not really. Think it's not fully on a news website. What do we have? 8 and 9. Which ones are less? And both of these are international.
Tencent.
What?
Tencent.
Yeah. So Tencent QQ. I don't quite know what this one is. Is this a naughty one? No. They have the porn websites, and those are a little bit further down. Is QQ like instant messaging in China?
Yeah.
Okay, like it's like a Reddit, Twitter alternative sort of. Yeah, and then the last one, oh no, this one is 9 actually. So it's Tencent QQ is 9. You're missing one big part of the world. Think part of the world. We have a bunch of US-based ones, 2 Chinese, and
Japan.
where else has a lot of people? India. What's the top website in India? Apparently. Okay. All right. So this is based on Wikipedia, but they have a couple of like ways of ranking them, and they're pretty consistent. So
What's number 11? Just out of curiosity.
number 11 is Taobao, which is online shopping. Yeah. And then Twitter, and then Tmail, which is actually online shopping, and then Google Japan, VK, which is a Russian social network website, Instagram, Windows Live, and so forth. Okay, so this just gives you a sense of what's popular. So Yahoo is still a pretty popular entity. Okay, so where are we? Okay, okay, so all of this is not PageRank. Okay, so back in the day when this is how the web worked, it was either these indices or these search engines that could use hyperlinks in various ways, but were semi-effective, right? They worked pretty well, but these spam websites could spoof them. They were spoofable. Okay. Yeah. So in order to do PageRank, okay, there were a couple of new ideas that that was brought to the table by Google here, and they kind of combine them together. Okay, so the first idea is that these hyperlinks were really useful, but they didn't want to just use the text. They want to say that pages are important if linked to by other important pages. Okay? So if there's a page, so like, you basically want to say if a page is linked to a lot of times, that should help. Right? But if it's linked to a lot of times by pages that no one goes to, then this is not as helpful. But if someone like Yahoo or Link or LookSmart kind of says this isn't the best page on Pi, then you kind of trust them. So you want to, Yahoo's index was online, so why don't use that? As Wikipedia was becoming online, you should use this index to say this is probably an important page. I want to, if this links to it, that helps. So I want the number of times it's linked to and how important the page linking is to that page. Right, now the problem is, how do I know that, I know maybe that the Yahoo index and Wikipedia, I forget when that was, how popular it was then. Maybe I trust those somewhat, but I don't know, I want to kind of do this automatically. I want to know, are there other good web pages that I trust those as well? So there's kind of a chicken and egg problem, and then I didn't know how to score the importance of web pages in order to say how important it was that they linked to it. Right? So I want to combine this with the second idea, number 2, that how likely a random surfer and just someone browsing the web would find this page. Right? So how likely would a random surfer find this page? Right? So I could simulate this by if my crawler, which I'm deploying across the web, if the crawler keeps coming back to this page over and over again, well, that's good. Right? That indicates that, I must keep finding it. It's not just that a lot of important pages link to it, but that somehow it's randomly surfing and that this is finding this page again. Right? So I can keep statistics on the crawlers. This was one way. But this seemed kind of slow, and and it wasn't really kind of very reliably necessary. Okay, so what kind of mathematical idea would tie these things together?
The Markov chain?
Markov chains, yes. So their main idea was we're going to model this as a model the web as a giant Markov chain, right? As a model of the web graph, right? And then we know if it's a Markov chain, if it's ergodic and all that, then the stable state vector I can kind of compute using analysis or these these other ways I can iteratively do this, and I can pre-process that, right? And then I can get this steady state vector and use this to say how important a web page. And it's basically tying together these ideas. Like the steady state vector is going to be higher for this web page if a random surfer is going to find it. And basically, because of this delicate balance property and so forth, if there's an important page, that means that a random surfer is there, and if it links to my web page, then I'm likely that I get more weight because an important page linked to me than if an unimportant page that no one ever went to linked to me. Okay, so let's combine these things together if I can model the web as a Markov chains. The big question is, though, is a web graph going to be ergodic? Okay, if it's not ergodic, then I don't really know if I can use this Markov chain analysis. Okay, and so so if you look at like,
Where would your course website be?
where would my course website be? It would be in here someplace, right? I link to my personal website, which links to the University of Utah website, which links to all sorts of stuff. Like if you link to, I probably link to Wikipedia on my course website, and eventually that links to the University of Utah, which eventually links back to me, right? So it's all strongly connected.
But could it use proper search engine be the link that connects?
Is to compute Q star, which is going to be P to some N times some Q0, and P is this big matrix, right? So P is M by M, right? It's all the links from one page to another, right? So, this is the page for data mining, and it has, links to a bunch of these other pages, right? And so if I actually add in links to all of these other pages in here, this becomes a dense matrix, right? And then I would normalize this, so this would be 1 over, let's say I've got 100 links on my page, each of these is 1 over 100, right? But if I add a 15% chance, I would multiply these by 0.85 and add 0.15 to all of these to divided by the total number. This in a simpler way, I get ones matrix, or in all ones divided by M matrix. So Q is all, this is describing, if I think of this is describing the probability transition matrix, call this P prime, then this is going to be ergodic. P prime to the N of Q0, this is called the...
Some pages that are very much related to what you're looking for, but there's some other much more important pages that are not that related to that.
Yeah.
So wouldn't this rank those other pages before?
Yeah, so think of, I'm computing some similarity score between the search term and all the web pages based on characteristics of those web pages. And I want to kind of get some accumulated similarity score, which is based on the text, based on the hyperlink text, and based on this Q star vector. So Q star is just a constant that's added to the similarity score of every page. And then it also has to do with the other part. And how they do this, Google does not release on purpose. They keep it a little bit hidden to prevent these spammers from trying to spoof it in some way. If they can figure out the formula, then they can kind of figure out what's going on. And that's traditionally how it's worked. There's some new European laws coming on the books about privacy, and they might have to release something. It's not clear entirely. I don't think they'll have to release this algorithm, but they'll have to start releasing other information about how they actually put ads on web pages, I think. At least how they use your data to do that.
So, from what I understood, you said that it's the likelihood of ending up on that web page, right?
If you're a random surfer who once out of every about 7 clicks does some magic step and goes to a random web page.
So what if you're trying to find something that's very rare, then you'd put that's not a very popular website, but the content is more relevant.
Right, so then what's going to happen is the similarity score based on the text is going to hopefully overwhelm the high PageRank score.
Okay.
Right, so they somehow combine these together in somewhat of a magical way that they don't release that might be changing. Yeah, so if you just do it with the P matrix, it doesn't work, because if you start anywhere, you're eventually going to get all of the PageRank score in these and none in here. Right, so it just didn't work without the teleportation.
Was that a common way to deal with non-ergodic graphs for the Markov chains before, or was that?
I believe there was some place in the literature. I'll tell you a story. I was an undergrad, which is around when this came out. It was after this came out, but it wasn't really well known. Like, I was taking a graduate class in a math class on Markov Chains, and I proposed something like this for another problem, and the professor hadn't known about this idea, right? He was a math professor, so he wasn't totally tuned in, but I don't think it was a totally common idea. That's my guess. So I think they kind of realized that this was a problem about the web graph and came up with this teleportation idea to fix it. It may have been known in some circles, and that's probably the case, but I think they kind of figured, that was one of their key insights to make this work, and that was not entirely obvious. Yeah, that you would do this.
Is the B matrix, or is that used in other places where there's graphs in
It's-
on the product?
Yeah, this is used in other places now, right? In dealing, when you want to do a PageRank type analysis, this is a way to stabilize it. There's actually some ways that you can show that doing this relates to some regularization problems for other data analysis problems on graphs. If you want to regularize somehow a machine learning algorithm on graphs, you add something. They've come up with this independently, and it turns out mathematically it's equivalent to doing this. And this is kind of a way of making the whole process stable, in that it makes it biased in some ways, but typically the power of the resulting vector better. Right? So this is now a fairly standard thing to do across a lot of, when you want to do graph analysis, figure out the most important nodes. This is kind of a stabler way of doing it.
We use this in physics for constrained parameters of relationships. So you do a random jump, just in case you're caught in the local minimum. So it's a true minimum, then you would work your way back.
Yeah. Great, thanks. Okay. Want to talk about a few more things. So this was not the end of the story. So Google came out with this. I think it was '98, right? I think PageRank came out, and it's really. But what is PageRank going to do on this graph? Right? Which nodes are going to get the highest PageRank score? Yeah, it's still going to be these two nodes down here. These two nodes are still going to be, because if I'm basically allowed to take 7 steps before I jump to someplace random. So if I try and what these spam farms would do, so this would be, and then this would be the spam farm. Okay, so I'm going to create a bunch of these web pages which I control, and then I sell to other web pages who want to get promoted. I put links on these a bunch of these web pages pointing here. And I don't want to put too many links, so if I get to this web page, I'm going to jump to one of the small number of ones I'm sell links on here for money, because it elevates the rank of these web pages. And then I need to have a lot of other web pages that link here, which are part of the main connected component. So how would I architect this as a company? How would you get links coming from in here onto these web pages? So a common way, and this will kind of give you a sense of other things, is blog comments. Okay? So if you see a blog, and some blogs are actually fairly about the opposite, here see my opinion. Right now, if you write blogs for academic, I read some academic blogs, people will actually, this is a somewhat reasonable thing to write, and they'll reply in their own blog. But these blog comments will actually link to these spam farm pages. Place these in you can put them inside Wikipedia articles, right? There's a page that's not very carefully controlled, you can put links into here in this way, right? You can figure out places to put hyperlinks. And if you put enough of them to these pages here, then these can be used to promote these other pages. Okay, and there's an industry of trying to do this. And okay, so they try and do this. Now Google will try and detect these spam farms and then kind of take them out of the probability transition matrix that it uses for PageRank. So it's not quite this obvious looking as going on here, but they still try and do stuff like this. They try and make these look like realistic pages. I'm sure some of you have accidentally stumbled on pages. They look kind of like real pages, but they're really nonsense, and then they link to some odd stuff. Okay, and that's what's actually going on. So it's hard to detect it if you do it right, but this is the general structure that's going on. But still, PageRank does a pretty good job of it. They can downweight blog comment links as opposed, inside the blog comments. Although sometimes those are useful, and they could try and downweight other things it doesn't trust as much. Right? Okay. You can also, if you hack someone's web page, you can add links like this, and this also happens. Yeah.
How are ads treated in search indexing?
Yeah, I'm not entirely sure. It might use them. Ads are kind of like dynamic, right? They're typically dynamic in that they're actually served every time you view a page. Google and actually Adobe has a system that does this. In other places, they will have some real estate that they will automatically generate an ad based on somehow it tries to make a profile of you and makes it relevant for you. So those might not show up in the HTML that a crawler would see. But if it does, then it would treat it the same way. It depends on how clearly defined the ads are. Like if a pop-up blocker can block an ad, a crawler should be able to as well. Right. So, but an ad, if you might pay someone with a really high PageRank page to put a link on their web page, or kind of if it's a friend of yours has a high-profile page, you put a link to your web. You get them to put a link to your web page on it. I know people who've done this. I don't think it's needed as much anymore, but like 10 years ago, this was a common practice. You had a friend who had a good web page, you would kind of, please put a link to my web page on your web page. We're basically out of time. I mentioned there's a couple of things called trust rank where they try and weight. They keep of web pages that they trust more than others, and they look at the PageRank score versus without using these trusted web pages, and where you only teleport to the trusted web pages. And if that differs a lot, that's an indication it might be a spam web page. It might be, it might not be, but sometimes if they're drastically different. And then there's this thing called personalized PageRank. Your search results are different than my search results if we're both logged into Google. And so what it does is it tries to create like an eigen decomposition of the probability transition matrix, and then it kind of weights it based on some personalization vector for each of you. And now it could do this, and it could then iteratively solve this for each of you, but this would not be feasible. So it needs to kind of somehow reweight the actual PageRank vector based on your personalization vector in some way. And they use this personalized PageRank as well, and this is how you get personalized search results. Something I want to mention, which is kind of maybe more of an ethics question I'll leave you with, is Google. I saw this paper, and I put this in the notes. In 2015, they proposed to measure their kind of add a truthiness score to their web pages. Okay, about how truthful the information was on their web page. And it's a little bit different than how much did they trust it automatically, but they would, I think they had, and they didn't completely outline this, but they were thinking of having someone go through and kind of validate whether this web page was fake news or was not fake news, right? And in some way, before this was a big thing. This was in 2015, and there was a big negative pushback on this idea. And the negative pushback was that I don't want Google telling me what's true and what's not true. Okay? And Facebook tried to do something similar. There's a similar ecosystem with Facebook now. It has a recommended things to look at, and that's based on what other people look at. And this, you get into like these people tend to get into these smaller environments where people similar to you look at similar things, and this personalized PageRank kind of makes it so you get in this information bubble. And they were trying to kind of score the truthfulness of certain news articles. And again, there was a big pushback against this because they're like, who's Facebook to tell us what's true and what's not true? And then, so they automated all of this, and then companies came along before the election, and for better or worse, they were able to kind of use the underlying analysis to use ideas like spam farms and so forth to elevate certain content, right? And so there's not a good solution for this right now, right? I know I've talked to a lot of people like is there a way to try and regulate this without introducing bias one way or another? How do you prevent people from kind of spoofing your automatic ranking system for better or worse? Who's to be the judge of whether something is truthy or not? The concern was Google would hide information about itself, right? If there was bad publicity about Google, that would never show up in their search results, right? That was the fear, right? And they probably do some amount of this, but I get the sense it's not totally kind of it's not like very draconian. You can still find bad news about them. So there are these questions about how to do this. Like when I was giving this lecture, even like roughly 2 years ago, I was pretty confident we were out in front of the spammers. We had developed better technology that could give a fair view of the web based on automatic algorithms. I'm much more pessimistic about this now. This has gone back and forth. Like every 2 or 3 years, someone else seems to have the upper hand. And it seemed like spam, like in your email, had gone so much better, and that was because advances in data mining machine learning, right? They'd figure out how to do this better, and similarly with this search stuff, right? Now it seems I'm not as convinced anymore. So I don't know. There's some like major challenges how to do this the right way. How much should be automated? How much should be curated? Should everything be like a newspaper with an editorial board that is trusted? Maybe, I'm not sure this solves the problem either, right? So who's watching the watchman, right? So this is a major challenge for the community right now, and there aren't obvious good answers. So the answer might be in policy. Right now, like Mark Zuckerberg, the last 2 days have been testifying in front of Senate and Congress. That didn't give me much hope if you watch any of those things. So that's going to generate some helpful oversight onto this. I don't know. Okay, so I'll leave you with this. Okay, so hopefully you can go out and change the world for the better. So.
You mentioned last month, how can you start using Python?
Yes.
So in practice, do you